Okay, so we're going to explore properties of exponents and to simplify roots. First thing you guys need to do in order to do this effectively is part A. It says to memorize. You need to know the squares up to 15. So all the squares up to 15, from squaring 1 all the way up to 15, you guys need to have those memorized. Most of you have probably up to 10 memorized, so make sure 11, 12, 13, 14, 15, you get those memorized. Same thing with the cubes up to 10. Typically, you guys are probably good up to like 5 cubed, but we need to work on 6, 7, 8, 9, and 10 cubed, all right? The other thing that we're going to need are the exponent rules. In order to be able to solve these problems, we need to know the rules of exponents. All right, the first one is x to the 0 equals 1, which means anything I have, if I have like x, actually I'm going to erase that, sorry. Let's erase this. Let's put a number on that just to make it constant. So let's say I do 5 to the 0 power. Anything to the 0 power, any number whatsoever is going to be 1. All right. The second rule is when I'm multiplying exponents, meaning if I had like x squared times x to the third, what I'm really going to do with those things is when I multiply exponents, I add them. So that would wind up being x to the fifth. The third rule is division of exponents. If I divide exponents, I actually subtract them. So if I had something like x to the fifth, let's say over x squared, that would give me x to the third, because I do 5 minus 2 is 3. You subtract them. You could also think about it as dividing into it. Like I could take 2 out of the bottom and it would leave me with 3 on the top, and both of those are doing the same exact thing. All right, let's look at property number 4. And now we have two things. We have an a and a b, and it's raised to the n power. All right, what we're going to do is if I have two things to a power, I'm just going to raise each of those to the power. So what I mean by that, if I had, let's say, x, y quantity squared, just make sure you don't do one of the variables, you do both of them. So it'd be x squared times y squared. All right, property 5 is called the power to a power property. Because if I have something to a power and raise it to a power, I'm going to multiply those exponents together. So if I have x to the third and I square that, since I'm to a power and I'm raising it to a power, I'm going to multiply, and now I'm going to get 6. So you see the difference between multiplying exponents and adding them and power to a power multiplying. Number 6, if I have a fraction to a power, similar to number 4, I just need to make sure I do the top to the power and the bottom, so numerator and denominator. So if I did x over y, let's say squared, it would wind up being x squared over y squared. All right. And the last one we're going to talk a lot about today is negative exponents. If I have a number to a negative exponent, in order to make that exponent positive, I have to move it. So if it's in the numerator, it's going to become in the denominator and become positive. So an example of that is if I have like x to the negative 2, you don't ever want to leave negative exponents. So I would have to move that and make it 1 over x squared. So I move to the denominator and make it positive. Okay. However, make sure you think, if I ever have something, let me just switch that. If I have like 1 over x to the negative 2, if it's in the denominator, to make it positive, I move it up to the numerator. So the rule works both ways, but whenever you have a negative, you have to move it to the opposite part of the fraction and then make it positive. So using those rules and knowing the squares up to 15 and cubes up to 10, we're going to do part C, which is to simplify and rewrite using positive exponents. All right, so first problem. You only have those 7 rules or so, okay? So please make sure to refer back to those rules. If I look at the first problem, I'm just going to do this part first. So I'm going to say, okay, I've got 2 terms here, the 4 and the a cubed, and I'm going to raise them both to the second power. So 4 to the second power, okay? 4 squared is 16. Make sure you don't put 8 there, because 4 squared is a number, and that has different rules than the exponent. Now if I have a to the third squared, that's power to a power, I multiply those, so that's a to the 6. All right, so that was my first set of parentheses. My second set of parentheses, again, I do 3 to the third power and then b squared to the third power. Well, 3 to the third is not 9, it's 3 to the third power, 3 times 3 times 3, so that's 27. And then since I have b squared cubed, it's power to a power, I'm going to get b to the 6. All right, I want to simplify as much as possible. My a's and my b's I can't combine. But if I do 16 times 27, that's going to give me 432. And then I'm going to leave my a to the 6th and b to the 6th. And that would be my final answer. All right, let's go ahead and do number 2. So I'm going to do the parentheses first, kind of order of operations. I'm going to do the numerator first. I'm going to do -2 to the 4th power. Okay, be careful. Again, rules for numbers. If I did -2 to the 4th power, that is not going to get me 8. I have to do -2 times -2 times -2 times -2 times -2. That's going to wind up giving me a positive 16. X, if it was squared and then raised to the 4th, I'm going to multiply and get 8. The y is to the 3rd to the 4th, so I'm going to multiply and get 12. And then my denominator was 8x cubed y to the 6. However, if I can simplify that more, which I can, I want to do that, meaning I could say 8 goes into 16 2 times, all right? 3 of these go into 8 of these. I'm going to kind of do this. I'm going to make my answer fraction. I know I have a 2 on the top. If I have 8 on the top and 3 on the bottom, I can cancel 3, and I'd have 5 left over. If I have 12 on top and 6 on the bottom, I'm going to get 6 on the top because I would subtract 12 minus 6. Or you could say, again, these 6 cancel with these, and I get y to the 6. Now, my denominator is really 1, so I'm just going to kind of circle my answer. My answer is just 2x to the 5th, y to the 6. All right, go ahead and try number 3. Pause the video and come back in about 15 seconds or when you're done and check your answer. All right, so if we look at number 3, I'm going to go ahead and say, okay, I know this is going to be a fraction. I'm going to reduce the 4 and the 6. I'm going to divide them both by 2 to get -2/3. Now, I have x squared up top and x fourth at the bottom. I'm going to have an x squared left. Here's the reason why. If you do x to the 2nd and I subtract, I have x to the 2nd and I'm dividing by x to the 4th. What I'm doing is I'm doing 2 minus, right, 4. Well, 2 minus 4 is really -2, which means it's x to the -2. Well, x to the -2 needs to go to the bottom and become positive. So a lot of times, I guess my point is, I would rather you cancel. I think it's simpler than using the division rule, which is subtracting. However, both of those methods will work. So like if I look at y to the 3rd and y, I could do 3 minus 1, because that's really 1, is y squared, and put it up top. Or you could say, let me cancel one of these y's with one of these y's and get y squared. So whatever's simplest to you, make sure you go ahead and use that. I'm going to go ahead and make that smaller so it doesn't look so, make sure it looks like an exponent. All right, so -2y squared over 3x squared. All right, let's move on to number 4. So number 4, I've got parenthesis to a power and another parenthesis to a power. So let's do each of those separately, and then we'll worry about combining them. So I'm going to say 7 squared is 49. X squared squared is x to the 4th. And then -4 times 2 is -8. And I'm just going to leave it for now. I'm going to simplify the second parentheses, 2 to the -3rd. I'm going to leave that for a minute because I'm going to come back and work that out with you. But then I'm going to get x to the -3rd and y to the -3rd. Okay, I see I'm going to have negative exponents, so that tells me pretty much straight away that I'm going to have a fraction for sure. Like I'm going to have things on the top and the bottom. I know 49 goes up top because it's just a positive number. X to the 4th will go up top. I'm going to move this y to the 8th to the bottom because I know all negative exponents need to be moved and changed to positive. All right, 2 to the -3. What that really means is it's going to be 2 to the positive 3rd down here. And I can simplify that in a minute. All right, x to the -3rd comes down, become a positive 3rd, and then y comes down to be positive. Now, I can simplify this again because I want to combine x's and put numbers together and stuff like that. The numerator, I've got 49x to the 4th. The denominator, well, 2 cubed is 8. Let's put that out front. I have y to the 8th and y to the 3rd. So I can add those because now you're doing y to the 8th times y to the 3rd. The rule for multiplication is I'm going to add those. So sorry, let me put my x in first because I didn't have anybody to combine with, and I'm going to say y to the 11th. Now I only have one more step because I can cancel the x's, meaning I have 4 up top and 3 in the bottom. I can cancel these 3 with 1 here. So I would get 49x all over 8y to the 11th, and that would be my final answer. All right. On number 5, I've got a fraction to a negative exponent. There are many ways of doing these problems, okay? My suggestion is let's just take everything to the negative power, and then we'll wind up moving it. meaning I'm going to get 3 to the negative second, x to the, well, negative 3 times negative 2 is actually positive 6. I'm doing a power to a power, so I'm multiplying, and negative is positive. My y is going to be 2 times negative 2, so negative 4. All right? Because I know I have positive and negative exponents, I'm going to make a fraction because I know my answer is going to be a fraction. I know x to the 6 stays up top because he's a positive exponent. I'm going to have to move down the y to the 4th. I'm also going to have to move down the 3 to the negative 2. That would become 3 squared. So 3 squared would really be 9, but it would have to be in the denominator because it's a negative exponent. Since I can't simplify anymore, I'm good. All right. On your paper, I messed this up when I typed it. Yours should say a squared b cubed over c. And then I think yours says a c cubed all over b. So this is what your paper should look like. So let's do the problem that you have. So what I would do, and there's, again, multiple ways of doing these problems. What I would do is I'm just going to make a fraction and simplify. Hold on. So what I mean by that is I'm going to say a squared times a. Well, that's really a to the 3rd power. All right. If I have b cubed, there's nothing to add to it, so I'm going to put b cubed up here. And then if I have c cubed, I'm going to add it up here. The denominator is just c times b. I'm just going to put it in alphabetical order, but it's just bc. So I would combine first, just because that's what I think is the easiest, and then I'm going to cancel one of these b's with one of these b's, one of these c's with one of these c's, and it looks like you would get a cubed, b squared, c squared. All right? So there are 6 different examples, and there's an infinite amount of ways that they can use the 7 properties we talked about. Please make sure you're wary of those properties. These rules are what's going to allow you to solve those problems correctly. You need to know when you have anything to the 0 power, it's 1. When you multiply exponents, you add. When you divide, you subtract. When you do power to over power, you take both of the exponents and I multiply, all right? And then negative exponents I have to move. All right, second section is just going to be on, whoops, I guess I moved that down. I don't know why those moved down. I wonder if I can, oh. Sorry, this is still the first section on your notes. Let me erase this and this. I have to do 7 and 8. I'm sorry. So let's see. Where's my pen? All right, let's do negative 4x to the negative 2, y to the 3 to the negative 3. What I would do, again, this is how I do it. I would say negative 4 to the negative 3rd power, x to the, multiply those together so you get 6, and then 3 times 3 is negative 9. What I'm going to do is I'm going to leave the x to the 6. I know I have to move y9 down because it's a negative exponent. This is also going to move down because it's a negative exponent. Doesn't matter that it's a negative or positive number, but because I have a negative exponent, it's really going to be like 1 over negative 4 to the 3rd. So what I'm doing is negative 4 to the 3rd power, and now be careful because it's negative 4 cubed. Your answers are going to wind up being negative. Okay, so I'm going to have negative 64 in the denominator with my y to the 9th. All right, last one, anything to the 0 power. This doesn't matter what is in here, but anything to the 0 power, this is just 1, right? Plus 5 to the 0 power is 1. So my answer to this problem is 1 plus 1, it's really 2. All right, second section. Let's go down to part D. Now, we're going to simplify using the real number system. All right, if I'm simplifying using the real number system, I'm not doing imaginary numbers. So there's going to be no i's. So meaning for like number 1, I cannot take the square root of negative 25, right? What you're going to write for this chapter is DNE. And what that stands for is does not exist. All right, it does not exist. We're not making that 5i. Right, we're not doing the imaginary number system. We're only working with a real number system. So when I have the square root of any negative, it's going to be does not exist. Using that same concept, if I'm taking the 4th root, there is no way I can multiply something by itself 4 times and it become negative. It will never work. Even if they're all negative, that's going to wind up being positive. So any even power, this would also be does not exist because I will never have a negative number or a positive number multiply by itself an even number of times and get a negative answer. So those two are D and E. All right. Now, number 3, can I take the cube root of a negative? Well, think about this. Cube root means I multiply it by itself 3 times. I know 3 times 3 times 3 is 27. If I put in negatives here, This would be 9 times negative 3, which is negative 27. That will work. So be careful that cube roots you can take, or basically any odd roots, you can take negative roots. Evens you cannot. All right? If we do number 4, the fourth root of 16 means what number times itself 4 times would give me 16. Well, what times what times what times what gives me 16? This is just going to be 2. Right? If I do the cube root of negative 8. Now, don't put D and E, because for odd roots, you can see if you can actually solve them. Well, what times what times what gives me negative 8? Well, if I do 2, I know 2 times 2 times 2 is 8, but if I do negative 2, that would indeed get me negative 8. So the cube root of negative 8 is negative 2. Now, if we go to number 6, and I'm doing the square root of negative 4. Okay, don't get confused there. Make sure odd exponents, I'm good pulling out negatives. Evens, this would not exist. All right, so be careful that we're working only in the real number system here, so we're not working with i's. Now, let's look at number 7. It asks you for the cube root of negative 729. I can do the cube root of a negative, so I know that will work. This is where you need to have those memorized. 729 is negative 9 times negative 9 times negative 9. You need to know the cubes up to 15 so that number looks more familiar. All right, look at number 8. This is a square root, all right? A square root, what this actually means, if this helps some of you, you're really just taking the square root individually of each of these things, okay? So I say, oh, what's a square root of 4? Well, I know that's 2. That's going to come out of the radical. Now, x to the 7th, that is not a perfect square, meaning I don't have, if I were to actually write that out, hold on, 1, 2, 3, 4, 5, 6, 7. I'm looking for pairs since I'm doing a square root. I have 3 pairs, right, that come out. So I can pull out an x cubed, but I'm still going to have an x left over in that radical. The shortcut kind of is if I have a square root, I want to divide this number by 2. Well, 7's not divisible by 2. 6 is divisible by 2. So I could do 6 divided by 2 is 3, but then I'd still have 1x over. So let's do the same thing with y to the 5th. 5 I can't divide by 2. So I know I'm going to have some stuff left over. If you go 1 less, y to the 4th, well, 4 divided by 2 is really 2, right? And then I would have 1 left over. Now z squared, well, 2 divided by 2 is just 1. That would just completely come out. So that would be my solution. All right. Then on number 9, you have to make sure you look at the index because we're not just doing square roots. We're doing squares, cubes, fourth roots, so you've got to be careful. Square root of x to the 6th, well, that's just going to wind up being 6 divided by 2, so it'd be 3 because there's 3 pairs of 2. Y to the 4th, 4 divided by 2 is just 2. Now, the z I can't do anything with, so I just need to leave that guy back in the radical because I don't have his square root of z. I can't simplify that any further. All right. Number 10. If I look at this, square root of 12 is not a perfect square, but if you were thinking about square root of 12 on its own and you did a factor tree, you would get 2 times 2 times 3. So 12, if I were to break that up itself, is 2 root 3. So you're doing just multiple problems in one. I know this is fine because this comes out. X to the 10th. 10 divided by 2 is 5, meaning I have 5 pairs, right? Y to the 3rd. 3 is not divisible by 2, but if you think about it, I would have 1 pair, so one of those would come out, and I'd have 1 left over, and that'd be my solution. So when I look at a problem like number 11, all right, there's things that look tricky, but they're a lot simpler than you think. So let me talk about the square root of 1 over 25. Right? This just really means if I wanted to simplify this, you guys could actually write this like this. X to the 230, y to the 4th over 25. Here's the point. Do I know the square root of 1? Well, I do. The square root of 1 is 1. And then do I know, do I know the square root of 25? I do know the square root of 25. The square root of 25 is just 5. But it would go in the denominator since I'm taking the square root of a number in the denominator. Then you also might say, well, oh my gosh, x to the 230. I don't know that. Well, the shortcut is if you look at y to the 4th, you're really just taking that exponent. I'm saying 4 divided by 2 is 2. I know I have 2 y's. We'll do the same exact thing. If I have an even number, 230, divide that by 2, I'm just going to get x to the 115. So use your rules and make things simpler. All right. Now, 12 and 13 are cube roots. All right. I need to find groups of 3. And again, you need to know that the cube root of 216 is 6. That's from you memorizing the cubes. Now, if I have x to the 18th, I'm looking for groups of 3. So I'm doing 18 divided by 3. Does that go in evenly? It does, so that'd be x to the 6. And then I move on to y. Y to the 30th. How many groups of 3 do I have? Well, 30 divided by 3 would be 10. And on the last one, we're going to do the same concept as 12, but everything's not going to be a perfect cube. Like 81, this kind of looks like a perfect cube, but it's not. Break it up on the side. I've got 9 times 9, which is 3 times 3 times 3 times 3. If I'm doing cube root, I want groups of 3s. So I could pull out a 3, right? But I'm still going to have left over in a cube root, I'm still going to have one of these 3's left over. Let's look at x to the 3rd. Well, 3 divided by 3, that is one group of x. And then y to the 19th. Well, y to the 19th is not divisible, like 19 is not divisible by 3. But a number less than that that is divisible by 3 is y to the 18th. So if I look at y to the 18th, I'm saying, oh, 18 divided by 3, I would have 6 groups. But that was only for y to the 18th. Since they're asking me for y to the 19th, I would still have one guy left over. Similarly, with y to the 4th. If I have 4 z's, right, that doesn't go in evenly, but I could pull out one group of 3, and then I still have one left over. All right? So review these notes, and we'll work on this stuff in class.